Hi, I'm Mitchell Fernberg. I'm a junior at Alfred State in the Mechanical Engineering Technology program.
I'm Luke Zink. I'm also a junior in the mechanical engineering program at Alfred State, and this is our senior project proposal. So basically, the scope of this project is to create a chemical fire suppression system for residential homes, and our main focus is on rural America. The reasoning that we're focusing on rural America it's due to several facts. The response time for volunteer fire departments is a lot slower than a full-time fire department. Um, and when it comes to putting out a fire, response time is key. Response time is the most important thing that you can have. The average response time for a full-time fire department within 1.5 road miles of the location is about 3 minutes, whereas the average time for a room to be fully engulfed in flames is around 5 minutes. So what we're going to do is we're thinking about creating a chemical-based fire suppression system. Now, it's different from a traditional water-based fire suppression system due to the fact that it's not charged with water, it's charged with some other chemical. The reason that we want to create a chemical-based fire system is because the reaction time is faster, the overall fire suppression is more effective than a water-based system, and it's just there are so many things that can be damaged in a house nowadays due to electronics, or whether it's just the flooring or the walls themselves damaged by the water. So using a chemical-based system, it should be a lot more practical. There should be a lot less damages. And overall, the fire suppression is more effective with chemical-based systems. Another reason that we're trying to implement these systems in rural America is the access to water. Now, if you are in a rural home, chances are you're not going to have a fire hydrant right outside of your house. So the volunteer fire department that comes to your house to put out the fire, they're going to need to bring their big tanker truck because they're not going to be able to hook to a hydrant, and heaven forbid they run out of water, you're not going to be able to save your house, and it's going to be a total loss. So that's one of the biggest reasons that we're focusing on rural America and implementing these systems in rural American homes.
So, with the goals for our project, one of them is cost effectiveness. With that being said, we took a survey with a bunch of adults over Thanksgiving break, and we asked them, because they were home, what would they be willing to spend on a system such as a chemical system in the house. They all said roughly about $6,000. That's ideal because most of the research we've done comes out that a system costs about $4,000. We realized with going on that, we can't put a price on life itself or put a price on safety. So overall, we're thinking our budget should be roughly about 10,000, and hopefully, after doing some more research, we can lower that cost.
So in existing fire suppression systems, there still are plenty of benefits. With your typical water charge system, some of the benefits are simply keeping the fire from spreading and a possibility of completely diminishing the fire. Now, these systems aren't designed to put out a fire completely, but in the rare case that the fire is small enough and the sprinkler heads react fast enough and start dispersing water all over the area quickly enough, um, they could completely put the fire out. But the main goal of a water charge system is simply just to keep the fire at bay until the authorities can get there. So that's one of the benefits of a water-based system.
And with disadvantages, with a water-based system, you have to have electricity going to the pump to run it. If the electricity goes out and there's a fire in your house, you're not going to have access to run the pump. Not many homes are going to have a backup generator that's going to kick on the pump. Also, with a water system, you will have water damage across the house. With appliances such as laptops and televisions in a house, that's a lot of money that's lost in the end. Not just the damage that goes along with walls and carpets and furniture. Um, Most water systems have to have a manual shutoff. If your house is on fire and burning down, you're not going to run back into the house to turn off the water. Say it's just in the kitchen. I mean, the water's going to go throughout the entire house. So with a chemical-based system, the benefits are quicker, they're less intrusive fire suppression. With that being said, the research we've conducted on most fire systems is they respond within 10 seconds after the system is activated, which is very quick. But prevents fires from spreading, which is huge because it can result in less loss in the fire. Also, no water damage. There might be a little bit of residue from the chemicals, but not enough to cause any damage to a building. With that being said, possibly the restoration team should go in still to verify that everything is clean and ready to go back in and the damage is not great. And another big thing that's a huge benefit is it's environmentally friendly. It's safe to animals, plants, and especially humans.
Some of the disadvantages, though, are simply the cost. The cost of these chemical-based systems are a lot more than a traditional water-based system. In a water-based system, all you do is you just tap into a water main and you run piping from that water main to the piping inside of the house, and you attach the heads to the piping inside the house or whatever building you're implementing the system into, and it's just a series of a couple valves that keep it from flowing backwards, or you have pressure relief valves that keep it from flowing too much and breaking the sprinkler heads. But those are very cost efficient, whereas these chemical systems, they're a little more costly. The system itself that we're thinking about implementing is about $4,000, and that's just for the chemical. That's not accounting for any installation cost itself. So that could be a disadvantage, but as we stated earlier, there's no price on life, and there's no cost that's too great to save a life. So some of the things that we're going to need to take into consideration for this project, one of the biggest ones is NFPA code. The NFPA, or the National Fire Protection Association, they have a series of codes and standards that you have to abide by when you're implementing any sort of fire suppression, fire safety system, and they're all about fire safety. So they have their set of codes and standards for things such as the piping, the sprinkler heads, everything that goes into making sure a system is safe. So we're going to have to research sprinkler head ratings for these chemical-based systems. There are different sprinkler head ratings, such as a height rating or the coverage area that they're rated for certain square footage. If they are set up too high or too low, you might need to implement a couple sprinklers in an area where you would only need one. A different ceiling height. There are different temperature ratings, so the filament in the middle breaks and whatever fluid is inside is discharged at different temperatures that the room reaches. So we would need to research that for residential homes and what we should use as a temperature rating for these residential environments. Also, we need to look up the pipe sizing and material, different chemicals that go inside of these pipes. You need different piping for your system itself. So I know that a glycol charge system needs galvanized iron, whereas a typical water system can just use black iron pipe. So that's going to be something that we're going to need to consider.
So when it comes to our system, we probably will need to use a pump. But if we're going with a chemical system, through the research from the United States, there's already a system out there called the e513, which is made by DuPont. It uses a heptafluoropropane to put out fires. It's very efficient. It's doesn't leave any residue. It's safe for humans. With that, we won't need a pump because the system itself is pressurized all the time, and as soon as it's activated, it releases the chemical. Now, if we find the cost is too great, we're going to change our idea and more than likely have to go to another retardant that will have to use a pump to push the flow through the entire system. With that pump, we'll need to find out the flow rate and the horsepower using calculations of Warner fluid mechanics to verify that the pump will be the right choice for the system.
As I stated earlier, there's NFPA codes for piping as well. If we do decide to use a pump, if we decide that the hydrofluoropropane is too expensive and we can't use it, we will use pumps to move the fluid through the system. In that, we will need to calculate for the friction factor and the diameter of the pipe and the pressure ratings for the pipe. And we'll have to also abide by the NFPA code with the pipe material and schedule as I previously stated, but we'll also have to abide by NFPA code with the flow rate of whatever fluid we're using to go through the sprinkler heads. Each sprinkler head is rated at a certain flow rate going through the head itself. So we're going to have to perform the calculations to reach that optimal flow rate through these sprinkler heads to make sure that the heads themselves are abiding to their standards that are set.
So when it comes to a reservoir tank, if we use a chemical-based system, we're not going to have a reservoir tank. The tanks come already fully filled to the building, and from there they're always charged in the lines until the system's activated. If we don't go without a chemical system, we do something else, we're going to have some kind of valve system to prevent backflow into the system. More than likely, it's not going to expel every bit of retardant. There's going to be still some up in the lines. And with that, we need a valve system to prevent the backflow. Tank size, it really comes down to the square footage of the house. We're not really sure what that's going to be based on because every house is different. Tank types, they're all relatively the same type. When it comes to building code, for a non-chemical based system, the tank itself has to be not in the house, but relatively close to prevent quick access time to the fire. And if it's a chemical based system, they recommend it to be just outside the room that is using the system. Therefore, the response time for the chemical to get there is much faster.
The fire retardant that we're considering to use is, as previously stated, a hydrofluoropropane. And in the system, or our system is going to be based off of the FM200 system that's aiding us in the design process, because this FM200 system is very similar to something that we're going to be implementing in these homes. If the HFP is not practical or desirable, as I previously stated, if it's too expensive, we're considering using a chemical similar to that of what's inside a fire extinguisher or a sodium bicarbonate. This chemical has already been proven to be able to put out fires, but certain tests will need to be run with this chemical based on the different BTUs that different materials when burning will put out. We need to make sure that this chemical that we put into our system is going to be good enough, basically, to be able to put out a wide range of fires that are, started from different materials. We need to make sure that the heat that's coming off of different materials burning, such as any sort of polyurethane material or a leather or wood or any sort of fabric, we need to make sure that it's going to be good enough to be able to suppress the fire on these materials. And so that's going to be something that we would conduct tests on if we decided to not use the HFP.
So implementing the households is really ultimately trying to find a cost-effective way to retrofit it. That being said, the short-term expense, which is the upfront cost, is going to be the overall system and installation into the household. It possibly could be very expensive. We're not really sure what the total cost will be. Our budget's still roughly $10,000, and that's where we're going. But when it comes to long-term savings, we realize the home insurance will go down due to having a burn system in your house. You'll save money there. Also, you can possibly refinance your house with having a fire suppression system because the chance of a loss due to fire will be less. Therefore, the resale value of your home should go up if you retrofit a fire suppression system into your household.
So in conclusion, we are going to try to find a cost-effective way to implement a chemical-based fire suppression system into residential homes, mainly in a rural setting. With my dad being a firefighter and with me living in a rural setting my entire life, I realize the importance of a system like this. I understand that the response time is critical. I understand that it's harder for a volunteer fire department to get to your house in ample time to make sure that the response time is quick enough to where your house isn't a complete loss. So I understand a lot of the basis of this research, and that's the main reason why we decided to try to design a system, a cost-effective system that will act quickly, act effectively, minimize damages from fire, water, smoke, albeit and ultimately to make homes safer and save lives.
Thank you for watching this presentation.
Did you like that little tidbit that I put in there?
Yeah, I thought you were going to say something.